In the last session, we have seen the problems of the hub. Typically, if I put it in one sentence, a hub just broadcasts any signal that it receives. So obviously, the higher end technology, which is switch, is going to eliminate at least that. In case of switch, what happens is when PC1 want to communicate with PC3, it sends a signal to the port where it is connected, and switch knows where exactly PC3 is. So it doesn't need to do a broadcast, but it can directly send that traffic to PC3. Now, there is a procedure of how it actually learns where PC1, PC2, PC3, PC4 are in their respective ports. That procedure is called switch learning. We will take that in probably one of the other sessions, but do know that switch has the capability to learn where the PCs are connected, and once it learns, it doesn't need to broadcast the messages. In fact, what it does is it switches the connection between PC1 and PC2, and it switches the communication packet from the port where PC1 is connected to PC3 is connected. And now when PC3 responds back, irrespective of how hub does, again switch doesn't need to broadcast it because it already knows that PC1 is being connected to its port. So it actually switches that traffic directly into PC1. This is how the communication in a switch happens, by eliminating all the problems of broadcasting that hub was actually doing. Now, there are different types of switches depending on the usage. For example, if you take a company, an organization, an enterprise, for example, we are going to use the switch in the access layer. There are different layers for that switch. So for the switches that are actually connecting these PCs and making the connection for the end devices, those set of switches are called the access layer switch, and those switches will be connecting these PCs, connecting the devices and devices. It also connects between the switches as needed. Once that connectivity is there, you will need a little bit higher end switch, which is able to take a little bit higher traffic, and their job is to consolidate this traffic wherever there is a need for the traffic from the switch 1 to communicate to a switch in the switch 2 or 3. For any reason it has to go higher and then consolidate that traffic. That is when you will be using the distribution layer switch. And we will see when that is actually required and stuff like that. But do remember, now there is an access layer switch and there is a distribution layer switch. And finally, if the packet has to go out of a particular site, then there will be a core level switch. Again, there are different functionalities which is been capabilities and functionalities which is being implemented at each of these layer. But at this moment, just do remember that the switches are not plainly used, but they are actually used depending on what traffic and policies that they have to kind of handle, right? So there is an access layer switch, there is a distribution layer switch, and there is a core switch. Now, if the packet has to go out, so this is how typically a switching environment topology is going to be in an enterprise. Almost typically a medium to large enterprise will look like. Now, if the packet has to go out of this site, so we can actually call this particular architecture as probably a site 1, right? There is a site A where there are end devices connecting, and there is an access layer switch, there is a distribution layer switch, and there is a core layer switch. Now, how about if there is a site similar like that called site B, and there is a PC which is in site A needs to communicate with a PC in site B? That is where we are going to get introduced into a new device called the routers. The fundamental and there are different modules in the router, there are different capabilities in the router, but by and large, this particular device, what it does is it actually allows the communication between two different sites which are geographically apart. So there will be connectivity from site A to the router. We typically call that as a gateway router, and there are multiple levels. As we have seen in the switch, there are multiple levels in the routers as well. We call it as a gateway router, then there is a core router, then there is an infrastructure. We'll get into that in a moment, but do remember that at a very high level, if you want to communicate two devices in two different sites, geographically separate, then there is a need of communication that has to be enabled through the router. Now, how, as I told, again, there are different layers here. So typically how it actually works is there are three tiers of ISPs. ISPs are, those people who actually provides you internet, the Comcast, the Airtel, like are some of those examples. So first, what happens is, let's say you are communicating from USA, and then there is a server which is sitting in India, and there is two devices which are sitting in India and US, and they want to communicate to each other. So it's geographically very, very distributed devices that are trying to communicate to each other. So what initially happens is the site A device is going to send the traffic right to the ISP 3 through the gateway router, in this example this one, and then ISP 3, whoever is your ISP, if it is in US, maybe it's a Comcast, and Comcast identifies that this communication has to go all the way to the other end of the world, so it needs now the connectivity to the tier 2. So it always establishes connectivity to the tier 2 ISPs, and the tier 2, which is which is having a larger coverage as such, it is now looking at where this IP address is actually, or where this device is sitting, and it identifies that it is not in my coverage. I will have to get the help of this tier 1 ISP, who is basically the guys who are providing the larger infrastructure for this internet to stay. You might have heard about the cables that are actually drawing through the ocean, which is the fiber cable. Those kind of these tier 1 ISPs are those kind of people. So now the packet actually initiates from the site A, it goes to the gateway router, it goes to tier 3 ISP. Tier 3 ISP identifies that this PC has to communicate to a different PC which is across the globe, and it actually sends the packet to the tier 2 ISPs, and tier 2 ISP, which is connected to the tier 1 ISP, it is going to use that tier 1 ISP's infrastructure to connect to send this packet to the tier 2 of the other end, and the same moves down to the tier 3 of the ISP in the site B, and finally it actually reaches site B device. There is a whole lot of things that is actually happening in here. It is not just the way we actually say that it actually routes and then goes. There is a hell lot of protocols involved in this. There is a hell lot of standards involved in this, and all the devices that are actually taking part right from the PC and the switch and the router, and in between all those devices that are actually communicating and making this communication possible. What we do is we make sure that the communication is seamless, and the protocols and standards are met. We will get more in detail, but at a high level, understand that this is how an internet is kind of built up, and these are the devices and the functionality and capabilities.